Hello, this is Jim McKeeth, and welcome to this CodeRage 9 session on FireUI and the MultiDevice Designer. FireUI is a new feature in XC7 and is the evolution of the FireMonkey Designer. It combines all of the FireMonkey application types into one application. So you no longer have to have a separate application for your Windows and OS X and another application for iOS and Android. They're all combined into one. And it's actually made up of three different technologies. The first technology that kind of is behind the scenes is called behavior services. And this provides runtime and design time platform design information. The second technology is called the MultiDevice Designer. And this is the designer that allows you to have design your UI once and then modify it and tweak it to get the perfect customization for all your platforms. And then the last part of the FireUI technology is the MultiView component. And this is an adaptive layout control that is just absolutely fabulous. So let's go and take a look at each part individually. First part, like I said, is behavior services. Behavior services is based on the idea that every platform is different and has different behaviors. So behavior services mostly runs behind the scenes, and it provides a way for your app and your user interface to adapt and know what the behavior should be like on the platform it's on, based on screen orientation, screen size, OS, etc. One of the ways you're going to see this is there's a new platform default size, platform default position, and platform default behavior on some of the controls. So for example, the T-tab controls tab position defaults now to platform default. And what this does is it puts the tab control, the tabs, on the bottom in iOS, because iOS says you should put your tabs on the bottom, and on the top for all the other platforms. You're also going to see the font size and font family have a platform default behavior, and many controls have a size platform default. And this sets the control size to be the default for the platform. That way you don't have to tweak the size of your buttons, for example, on different platforms. That automatically will adapt the correct size for the platform it's running on. So at runtime, if you want to access behavior services, you can. The main purpose of behavior services is that it can be used at design time to influence the behavior of your controls, but you can access the T behavior services class, which is in the FMX behaviors manager unit. So it defines, has two interfaces you can use. One is iBehavior or iDevice behavior, which defines the getDevice class, which will return a device class. GetOS platform, which will tell you if it's OS 10, Windows, iOS, or Android. And getDisplayMetrics. You can also use the iFont behavior interface to find out the default font family and the default font size. So here's an example of using it to get the device behavior, get the OS in this example. So we check to see if it is iOS, and if it is, first we have to check to see if it supports that iDevice behavior interface. And if it does, then we can use that to get the OS platform and check to see if it's iOS, and then have specific behavior for iOS. Here's an example using display metrics. So we get the display metrics from the device behavior and check for the aspect ratio, and then we do different behaviors depending on what the aspect ratio is. This is what the record of display metrics looks like as far as what it contains. It has the physical screen size, the logical screen size, and the difference is the physical screen size is the actual physical number of pixels on the screen, whereas the logical screen size is what the screen size is based on the pixels per inch, or the density of the screen. So for example, the simplest example is the original iPad had 1024 by 768 pixels. Then the new iPad Retina display had 4 times that, so it's twice as wide and twice as long, so 2048 instead of 1024. That was the physical screen size, was 2048 wide. But the logical size was still the same. It was still a logical screen size of 1024. Okay, so that's the difference between logical and physical. They also have the scale, font scale, aspect ratio, and pixels per inch there. So aspect ratio is going to tell you landscape versus portrait, for example. All right, so now let's take a look at the MultiDevice Designer. But the idea behind the MultiDevice Designer is you first create a master view, and the master view contains all your controls and lays out like you would normally lay things out. So you're going to use all your alignments and your anchors and your margins and your padding, etc., just like you did before on your master view. But then you can create device-specific views. And so you only create device-specific views on platforms where you want to tweak your layout. Okay, so you can move things around on different layout. So for example, on your iPad, you might lay things out differently than you would on your iPhone. This actually uses stream inheritance to only store the differences between the different views. So if you wanted to have components only visible on certain views and on other views, like I said before, they all exist on your master view, but you can then hide them on specific views. So if you don't want them on your iPhone because you don't have enough screen real estate on the iPhone, you would hide them on the iPhone and then have them visible, the visibility set to true on the iPad. So there's only one form class for all platforms. So your class file where you're writing your code, there's only one instance of that form. You only have one set of code that you're writing there for that. But then there's multiple FMX files. Now the main FMX file contains everything in it. And then the other ones, the ones that are specific to the device, are the stream inheritance, the difference between the main and that one. So it only contains the differences in there. And you can see here the code for how it references the multiple FMX files. So the compiler is only going to include the ones for the current platform. So if you have 5 different Androids and 4 different iOS FMX files, when you compile for Android, it's only going to include the Android ones. When you compile for iOS, it'll include the iOS ones, and it'll always include the main one. So the star.fmx is the main one, whereas the iPhone 4-inch .fmx is the iOS 4-inch specific one. Now it comes with a nice selection of default views that you can use, device views you can use, but if you want to add custom views, like for example, for the new Android Wear watches, you can certainly do that. And the information you need here, all you have to do is create a unit in a package that creates a tDevice add info, or calls tDevice add info in the initialization section, and then in the finalization section removes that device. And so in add device, you're going to define what that device looks like. Then you also have to use that unit at runtime. So that's really important, that the unit that defines that device needs to be used by your application at runtime so that you're able to define that device you're going to use. Now in the IDE, you're going to add a matching entry in that XML file, that mobiledevices.xml file that describes that device. Now I'll give you a link at the end that shows an example of how to build one of these. It's pretty straightforward, pretty easy to do. And you can build one of these or use the ones I've already built for the Moto 360 and the Galaxy Gear Live Android Wear watches. All right, now take a look at the TMultiView component. This is a fabulous component, very useful. The TMultiView component is a sort of a super panel. It's 4 different presentations in one. And actually it could be more than 4 technically, which I'll tell you a little about how the custom presentations work later. But the presentation between the 3 default ones depends on the device kind and orientation. So it automatically adapts to different form factors and orientations and platforms. So for example, in an iPad or a tablet landscape mode, you'll see the layout there at the bottom where it has the controls at the right or at the left. But then when you go to portrait mode, it hides that and makes it into a popover. So you can just tap a button and have it pop over. So the different parts of the TMultiView is the TMultiView itself is, in this example here, contains a list box where you see it has the little Acorn, Android, Apple, etc. That list box is on the TMultiView. Okay, and then the TMultiView has a property for a master button and a target control. So the master button is the button that the user taps when the multi-view is not visible to make the multi-view appear. So that button can actually disappear at different times depending on when it should be visible and when it should not be. You don't want to put the button on the multi-view because if the multi-view is not visible, then you can't tap the button to make the multi-view appear. You also have the target control. The target control is what the multi-view is going to appear over typically. So you're usually going to use like a T layout or maybe a T tab control, and it's going to contain other controls. Those are the main that's the main content area. The TMultiView is going to contain the stuff that's only occasionally visible. So it's either going to be, in the case of a tablet or a Windows application, OS 10 application, it's always there, but in other instances, it will be hidden until the button is tapped or the side is swiped, etc. So this is the different modes that you get by default. The platform default is going to automatically adapt the view for you. So this is the default one you're going to get. You say platform default and automatically adapts based on the platform and the orientation, etc. for you. So you don't have to worry about it at all. But if you want to select a specific view, you can certainly do that as well by changing the mode to popover. So popover is when the user taps the button, the master button, then it appears like you see there. And that's on iOS. On Android, it'll look a little different. So it's still going to behave the same and popping over, but the appearance will be slightly different because it's going to match the Android OS appearance. The drawer, which in my opinion is the coolest user interface paradigm ever, is where it comes in from the left-hand side. So it comes over the top from the left-hand side. You also notice there's an example that has a shadow there. That shadow is optional. You can change that as a property for that. And in this case, the button gets covered when it's opened. So you can tap the button and it'll slide, the drawer will slide out, or you can actually slide from the left, swipe from the left, and the drawer will slide out. And you can actually do it on either the left or the right, which is pretty cool. And then the panel is the docked panel. This is where it's always going to be visible and the button is always hidden because there's no reason to have a button because you don't need to tap to make it appear. So the panel is the one you're going to use when you always have enough real estate. So this is the default you're going to see on the iPad or a tablet in landscape mode or on OS 10 or Windows desktop applications. You also have a custom option. Now at the custom option, what you do is you implement TMultiView Presentation class. So you descend from the TMultiView Presentation class and implement it. There is a default one that you can see in the sample application that's available that just is an alert that pops up in the middle, but you can implement it to have it behave however you want to. You can have it push the master control to the right. You can have it do whatever you want to do. There's all sorts of possibilities there and how you have that behave. Some other behavior things you can do at runtime, though, is you can call hide master or show master to make the drawer open or close, as it were. You can also check to see the state of it. So you want to call has presenter, and has presenter is going to tell you if you have a presenter. Now the presenter is what is doing the presentation of the MultiView. It's the class that handles that. So you should, most of the time, you're going to have a presenter, but you want to call that anyway to make sure you have that assigned. And then you can call presenter.state, and that contains a set of installed, opened, or moving. And so those are the different states the control can be in. The presenter is installed, the presenter is opened, so it's got the drawer opened, or it's moving, either opened or closed. So I'm going to show you the process for creating your own view, your own custom view for part of FireUI. So by default, you have these views here available to you in XE7. These two are custom views I've created, so I'll show you how these are created now. So the first thing is you need to discover the physical and logical characteristics of the device you're targeting. So that's what this app here does. And the way it does it is to get the physical characteristics, the physical pixels per inch, the physical screen size, is we use the platform services display metrics. Once we get display metrics, then we're able to get the physical screen size width and height, as well as the pixels per inch. Now, the physical screen size is the actual physical number of pixels on the screen, right? And then we need to get the logical. Now, the logical size we get from this width and this height, so it's the width and height of the form. And this is the design time width and height of your application, of your display. And the difference has to do with the density, the pixel density. And then we need to get the class. And so the class we get through the device services. And the device service, we just say, we get the platform service, the device platform service, and we call device class. And we're using getting the enum name for that. So once we have all this put together, we can go ahead and run this on our device. So I'm going to go ahead and run this on my Galaxy Gear Live. And here it is running on the Galaxy Gear Live. And we'll see that the physical is 320 by 320. So this is the actual physical number of pixels on the screen. The logical is 213 by 213. And the PPI is 240. Now the class says tablet. This should actually say watch. But when XE7 was released, there were no actual watch devices available. And so the way the code is written is it looks for a phone, and if it's not a phone, it's a tablet or Google Glass if it's that possibility. So those are the only three possibilities it tests for. If it isn't Google Glass or a phone, then it defaults to tablet. So I would suspect in an update in the future, they'll fix this to actually report this as a watch. And there's other classes in there that can possibly report it as well. Now, once you have that information, then you can create this file here. Now, I'm showing you the Pascal version of the file, and the reason is because you want to do this in Pascal so that it can be reusable by either C++ or Pascal applications. If you really want to see the C++ code, if you consult the documentation for creating a custom view, you can find it there. So in here, we put in the physical size, 320 by 320, and the logical size, 213 by 213. Now you can actually do a minimum and a maximum. This is overloaded, so you can take different parameters, but I'm just doing exactly that size because we're targeting exactly this watch. For phones, for example, you be targeting phones in a size range, especially on Android phones. So the first parameter here is the class. So again, the class is tablet, and we'll notice the enumeration for this is 4 because you're going to need that in a minute. Then the view name, which our view name is Gear Live, and then the physical size, logical size, what platform we're on, Android, and the pixels per inch, 240. Now, exclusive means that we only want to use this on exact match, all right? So this is important to select when you're making a specialized device like a phone or Google Glass. I'm sorry, like a watch or Google Glass, because this way it won't ever adapt this view and use it for other devices. And then, so during the initialization, we define, add the device, finalization, remove it. Then what we can do is create a package and install this package. Now, in order for this view to be used at runtime by an application, you have to actually use this view. So if you look down here at my Hello FireUI app, it uses the Gear Live device. So it has to be used by your app at runtime, and that's the way it's able to discover this view and use it. So one thing I've done is I've created a component, and all this component does is use these two units. And it also reports what support devices it supports, but that's superfluous to the functionality. And so what you can do is then you can install this package. So this has to be installed as a package in design time for it to show up at design time. And then this component's also installed. And all I have to do is drag and drop that component onto your application, and you'll have those units used. So it's much easier than having to go and hunt these up and find them. So if you are using the custom view and your app doesn't take advantage of it at runtime, then either your physical or logical dimensions are wrong, or the most likely scenario is you forgot to use these units. And again, I'm showing you Pascal code, but you can look it up in the doc wiki for the C++ version of it if you'd rather do that. Okay, so once you've defined this here, then you have to modify this mobile devices XML file. Okay, so the mobile devices XML file is right here, and it's easiest if you just use this path here, app data roaming Embarcadero BDS 15.0 mobile devices XML, and you're going to come here and you're going to add these lines of XML. Now, one note about this is when you reboot the IDE, it loads this XML file, and if you screw up something in here, if the XML is malformed, it'll actually cut out the malformed XML so that the IDE can still boot. So I suggest you make a copy of this in another note, in your notepad or someplace else, so that just in case it does get messed up, you won't lose all your XML. Okay, so right here, device platform is 3. Remember, I told you that was important to remember that because this is the integer representation of that enumeration for tablet. 2 for Android, and then here we say 213 by 213, which is the logical size. We see right here, 213 by 213. And then this is the top and left of where to place the screen image inside the artwork. And so you have a path here provided to your artwork. And what I did is I went to Samsung's website and got one of the images for their Gear Live and resized it so that the screen size was 213 by 213, and then found the top left, 227 by 313. Once you have that, then you can create the artwork, or you can use that as artwork for your custom view. So update your XML file, save the changes, and restart your IDE. And so then you can come in here and you'll have that available, Gear Live, available as a view, or whatever their view you have to implement. So all my code of it is available here that you can download from the links at the end. So you can just download this and install this, and you'll have these Gear Live and Moto 360 already defined for you. And you can use that code to build your own custom views for other applications as well. So I have a pretty much new multi-device app. And you'll notice right away under new, we just have VCL or multi-device. So there's no FireMonkey desktop versus FireMonkey mobile. You come in here, this is the wizard you can use to select. And so this applies to a multi-device app that will run on both desktop and mobile. So this bar here is the new MultiDevice Designer view bar, and so we can change what style we're on. We're on the master view. We can change what style this is. So we say what it would look like on OS 10 versus iOS versus Android. So right off the bat, notice that the toolbar or the tab bar position or the tab control position changes when I go to iOS, and that's because the tab control, tab location, tab control, tab position is set to platform default. So platform default means it adapts to whatever platform we've selected. Okay, so that's the most common scenario you're going to run into the behavior services. You can also use it via code like I showed you in the slides. So now let's look at the way the MultiDevice Designer works. So if I come in here to the views, this gives me a list of all the potential views. Now these two are the custom views I added. The rest of these are stock views that come with XE7. So if we want to design this, basically what you're going to do is you're going to design your UI just like you did in XE6. You're going to set your alignment, set your anchors, your padding, and your margins, etc., to get it laid out the way you want to. But then on some platforms, you're going to want to tweak it. So let's go ahead and say, let's design it for Android 4-inch phone. So we're going to say on Android 4-inch phone, we'll make this button bigger, for example, and we'll change the text on the button to say Android 4-inch. Okay, so now if I go back to the master view, it still has button 1. Those changes didn't take effect, and that's because these changes are only applied to that specific view. So if I add a Android 7-inch tablet, and we'll go ahead and rotate this, we'll notice that again, this doesn't have that change assigned to it. Now if I go to the code, we'll see here that if I that it has the different devices here. So we have the two Android devices, the tablet and the phone. And if I say view as text, this is just going to show me the text for that particular view. Okay, so if I go back to view as form, and we'll go to the master, which we are on the master now, and say view as text, we'll see now this has all of the controls on it. And that's because we use form inheritance or stream inheritance to only store what's different between the different views. Okay, so let's say on my 7-inch tablet, I'm like, hey, I got a lot more real estate here. I want to add an additional button here. So we'll go ahead and add another button. Just put it on here. So one thing is this button got added to the master. So all components exist on the master. All right. So since it's on the master, that means it's also on our 4-inch phone. But we don't want a button on our 4-inch phone because we don't have enough screen real estate. So we come over here and we set the visibility to false. Okay, we can't delete it from here. Actually, we turn back visible. If I try and delete this, it says introduced an ancestor. That's because it's on the master view. So we can't delete it. We just set it to false, the visibility to false here. So it's still on our tablet, still on our master, but it's not on our 4-inch phone. Okay. If we want to make it visible again, we just simply select it from the list here, button 2, and set the visibility to true. So the thing about these views is you're going to probably do most of your designing at your master view and then only create these device specific views when you want to tweak your view specifically for that. So since I've just created a Android 4-inch phone view, that view will automatically get used for the 3.5 and the 5-inch phone. It'll just use the regular stretching anchors and alignments like we saw previously to make it fit on those as well. Okay, so you don't have to define it for every one of these, but you can. And that's the really cool thing, is you do all the work on your master form, and then you can tweak it on all these other views if you need to, but only if you need to. You don't have to. Okay, so this is really the maximum of reuse and the maximum flexibility all in one. The one thing here is the events. So if I set an event handler here on this one, and we'll say show message button 1, and then we'll go to our 4-inch phone. We saw that same event handler, but we can change it. This is actually kind of cool, is I can come here to the object inspector events, and I can delete that on-click event handler and make a new one here. Oops, I guess I want to give it a name. Call it Android click, and say show message Android 4-inch. Okay, so now when we're on Android 4-inch, it's going to have a different behavior than it would on any other devices. So we go to Android 7, the button 1 has still the original button 1 click. Okay. Other thing is that we can have this revert back. So here we'll change the text to say Android 7-inch. All right, and I can right click on this and say revert to inherited, and it's going to revert back to inherited. Or I can just change, if I just change the text, let's do the text here again, text, change, and then I can right click here. Let's see, I want to right click here and say revert to inherited, and that will change just that one property back. So you can change an entire control or just a property back. So that's the main things you need to know about the way the MultiDevice Designer works. Very cool, very slick, great way to customize your view and take maximum advantage of your effort across as many devices as possible. This is going to really become a big deal, especially on tablets, so the tablet view versus the phone view versus the watch view versus the desktop view. And then let's take a look at the MultiDevice Designer. So the MultiDevice Designer, I'm going to go ahead and run this here, is just an incredibly useful control. So right now we have our MultiDevice Designer, and this, like I said, this is the MultiDevice Designer here, or the TMultiView component here. This is the master area here, master control, which is what this would appear over it. So if we change, right now it's on platform default. On Windows, it just assumes we can display this all the time, so it's docked view. But we can go, or docked panel. But we can change it to drawer, which is my favorite view. And if I tap this, then the drawer comes out. Displays a nice little shadow over that. We tap back here and it goes away. On a mobile device, I can actually swipe from the left and it will bring the drawer out. Very cool UI paradigm. We can change the drawer position to the right. So now I tap this, it comes in from the right. And again, on a mobile device, if I swipe from the right, now it would come in from the right because that's where it's at. So you can change that way. You can. The shadow is also customizable as well. So right now it says the shadow turned on, but we can turn the shadow off. Boop. And now I bring the drawer in. There's no shadow there. Okay. So the other option is we can have it do popover. So popover is where it comes down like a pop-up menu. This is going to look different. So obviously here on Windows, it's overlapping off the edge. On Android, it is completely inside here, and on iOS it has a little arrow pointing out of it. So there's going to be differences on different platforms. Then there's the split view. Let's change this to, or I'm sorry, the split view. That's the dock panel, where the dock panel's at. And then so pop over and drawer, the two platform specific ones, and then you can also do custom. And so custom, you actually define that class that defines how the custom behavior works. And we just tap this. In this case, it's the alert custom, which is going to pop up in the middle, and we can turn the shadow back on again. And there it is with the shadow. Okay, so platform behavior is the default, and that's going to be the default behavior that's most common to that platform. But you can customize this. Always have it use a specific type of mode or customized behaviors of that, whether it be left, right, overlap. So you can do overlap and pushing, so we'll go back to drawer. So now it's going to push. So you see that it pushed this over instead of overlapped it. So very cool, very flexible, very customizable. Great way to maximize your UI across multiple platforms. So that was a short demonstration of FireUI, and here is a summary for you. Again, FireUI is made up of 3 parts. We have the behavior services. The idea every platform is different, and it allows the platform to it allows your application to automatically adapt to these different platforms without you having to write a lot of code to do that. The MultiDevice Designer allows you to have one form that can be different for each platform. So the cool thing is in here, you can still use anchors and alignments and not need to customize it for specific platforms. But if you want to, on certain platforms, you have that option. So this gives you the best of both ends of the spectrum. You can have full customization for each platform, or you can have full reuse for each platform, all combined together with the MultiDevice Designer. And the TMultiView component gives your app that really nice adaptive layout where it can have the common UI paradigms we see on mobile apps, and then also have the UI adapt to different screen sizes, different orientations, as well as desktop and mobile. For more information, check out these links here. The most important one's probably going to be that's down at the bottom, the slides and more, which is a link to a blog post that's going to give you a link to download the slides, and also have the replay of this video available there later. And it's going to link to some additional resources besides the ones you see here, like, for example, the Motos 360 and Galaxy Gear Live views that you can install, as well as possibly in the future more views will be available there as well. So check out that link for more information. And now if you joined us for the live session, we'll do some live Q&A.
Georgie, or Yorgi, I'm not sure, I'm sorry about if I'm clobbering your name, asks, can we use JSON for keeping parameters besides XML? You can use either. There's different libraries for parsing the information. We have a whole set of JSON conversion utilities, so you have that choice, as well as we have XML document. There's the XML document component and a whole set of XML functions for parsing. With XML document, you can choose the document object model, whether it's the Microsoft DOM, MS XML. We also have Omni XML now as a choice. So you can store however you want to encode the information, but JSON is the one that we tend to use these days and that most out in the world seem to be using. But again, in your own programs, you have all the choices to work with JSON or XML. I mean, it's pretty straightforward. The only thing I've noticed is remind yourself when you're in the IDE and you're in the master view versus the selected view, is just to remind yourself what you're on. And you get a visual cue. Once you're on a device view, then you don't have the different platform choices for looking at it for iOS OS 10 in the designer. You need to go back to the master view, and then you can choose to preview what it will look like on all the different choices. Once you select a device view, then the designer is going to show you what that looks like on iOS, Android, a watch, or whatever. So, and then let's see, Rob is asking how to debug run on different target devices. Well, to run them, you plug in the devices. So if they're Android devices, you can plug in through USB cable. I think one of the watches Jim has, he was going through Bluetooth, so it takes a little longer to send the package and then run it. But we have a debugging session in C++ with the R&D team on Thursday morning. I forget when that is, but you'll see debugging multi-device applications. And so there's different debuggers and debug servers on the different targets. And then we use the PA client, Platform Assistant Client, and Platform Assistant Server to get to the debugger on the platform to get to the debug server that's on the different devices. So Kevin, LDAP. Yeah. We don't have an LDAP component or RTL, but there's APIs on different platforms for doing LDAP operations. That's something that we're looking at. Jim Tierney is doing a session on enterprise mobility services, authentication and authorization. So you might ask Jim, and I'll queue that up for Jim, because Jim is responsible for the team doing data snap and doing EMS. So LDAP would fit right into the authentication authorization world, Kevin. So I'll make sure to ask that again when Jim Tierney is here. His session is, I think, tomorrow sometime. But look for the enterprise mobility services, authentication, authorization with Jim Tierney. Let's see. His is tomorrow at 11 a.m., Wednesday at 11 a.m. Enterprise mobility services, authentication, authorization. But again, Jim is the manager and developer and architect, and also it's got the team that does all the distributed computing authentication authorization. So I'll make sure and ask that question again and get that captured from Jim Tierney's perspective from R&D.